On June 23, 2026, the International Supercomputing Conference was held in Hamburg, Germany, where the 67th top 500 list of the world's fastest supercomputers was released. China's Lingsheng supercomputer topped the list for the first time with a sustained double-precision floating-point performance of 2.198 exascale operations per second. This marks the first time a Chinese supercomputer has topped the list since Sunway TaihuLight in 2017, besides Lingsheng. The other two supercomputers in the top 5 are the US's El Capitan, Frontier, and Aurora, and Germany's Jupiter. Lingsheng's entire system, from chips to the overall design, was independently developed in my country. Liu Yutong, chief designer of the Lingsheng supercomputer system and director of the National Supercomputing Center in Shenzhen, explained that Lingsheng is built upon several core technologies, including domestically produced high-performance CPUs, on-chip high-bandwidth memory, high-speed interconnect networks, high-throughput storage, three-dimensional floating orthogonal cooling, and full liquid cooling. The chip layer. It features the domestically developed LX2 CPU. At the network layer, the independently designed Lingqi high-speed interconnect network supports ultra-large-scale networking with 2 million ports and 100,000 nodes. The storage layer. It adopts a layered architecture, balancing high-performance workspaces and high-capacity data areas, and can be scaled up to exascale. Meanwhile, Lingsheng innovatively adopts the ABC design principle: application-driven, balanced architecture, and full-stack collaboration, achieving breakthroughs in 6 core technologies: converged architecture, high performance, high energy efficiency, high reliability, scalability, and ease of programming. In terms of high performance, the Lingsheng supercomputer pioneered the online acceleration hardware and software architecture, introducing multi-precision matrix acceleration computing units into the central processing unit, CPU, to achieve large-scale multi-precision hybrid computing capabilities. It is the world's first supercomputer to achieve a sustained performance breakthrough of 200 quadrillion floating-point operations per second in double-precision floating-point computing. Supercomputing systems generally face the challenge of increasing power consumption with higher performance. Lingsheng, however, pioneered a 100% liquid-cooled computer cabinet, achieving an energy efficiency ratio of 51 GFlops/W, 1 billion floating-point operations per second per watt. This sets a new benchmark for green computing while maintaining world-leading sustained computing performance. The Lingsheng supercomputing system is deployed at the National Supercomputing Center in Shenzhen, positioned as a domestically developed, full-stack, integrated infrastructure for intelligent computing in science and engineering. Lingsheng will effectively support the high-performance computing needs of fields such as atmospheric and oceanographic research, energy materials, industrial simulation, biomedicine, brain simulation, earthquake remote sensing, and large-scale model training and inference with higher computing efficiency and programmability. In the field of remote sensing, large-scale training and system optimization of remote sensing models are being conducted using Lingsheng. The end-to-end training peak performance is leading in this field, achieving high compression and efficient reconstruction of 8 years of global time series remote sensing imagery. Currently, related technologies support remote sensing interpretation and precipitation forecasting, significantly improving forecast accuracy and assisting in land monitoring and disaster early warning. In the field of bioinformatics, LingSheng has achieved virtual screening of trillions of compounds per day, combining AI reinforcement learning methods. Screening efficiency has been improved by 1,000-fold, which will strongly support innovative drug development and precision medicine. In the field of materials science, LingSheng has achieved first principles calculations at the level of 100 million atoms. Researchers can build atomic models in the supercomputer to simulate the molecular arrangement, strength, and high-temperature resistance of new alloys and semiconductor materials. New generation high-strength aerospace, aluminum materials, high-temperature resistant aerospace coatings, and chip materials can all be designed and tested in digital space before being put into production, thereby multiplying the iteration speed of new materials and filling gaps in domestically produced large aircraft, manned space flight, and high-end manufacturing. In the aerospace field, relying on LingSheng supercomputing, researchers can fully simulate the airflow, high temperature, and pressure changes of aircraft fuselages, rocket engines, and other aircraft during high-speed flight, and repeatedly optimize design schemes. A large number of experimental processes have been transferred from offline to online, greatly compressing the R&D cycle of aerospace projects, reducing material and financial investment, and promoting the rapid development of my country's aerospace industry. In response, Jack Dongarra, the 2021 Turing Award winner and American computer scientist, commented, "China's LingSheng system has shown the world the hope that supercomputing can lead to a new system architecture for AI for science." Against the backdrop of fierce competition in the global high-end computing power industry, the EU has invested €20 billion in building an Exascale supercomputing base. The US continues to upgrade its Frontier and Aurora systems, and China has achieved a technological overtake with LingSheng. This competition is not only about computing power performance, but also a comprehensive contest of basic scientific research capabilities, industrial chain autonomy, and application scenario. Ecosystem. LingSheng's victory marks China's shift from passive response to active leadership in the field of computing power. The 6 strategic values of LingSheng's achievement. LingSheng's achievement and its breakthrough in full-stack self-reliance have profound strategic value for China's computing power industry, mainly reflected in the following 6 aspects. First, breaking the technological blockade and reshaping the computing power landscape. In a global supercomputing paradigm that generally relies on GPU acceleration, LingSheng adopts a pure domestic CPU architecture, self-developed LX2 processor, deeply integrated with domestic HBM, high-bandwidth memory, without relying on overseas GPU accelerator cards. This breaks the monopoly of the CPU plus GPU heterogeneous architecture, proving that domestic CPU architecture can also achieve exascale computing power, providing a new technical route for the development of global supercomputing. For example, the LingSheng supercomputer boasts nearly 14 million computing cores, achieving highly efficient and scalable operation across the entire system with over 10 million cores. Its average scalability in a large-scale parallel environment reaches 84.4%, and its computing speed is more than 20% faster than the El Capitan supercomputer at Lawrence Livermore National Laboratory in the United States. The LingSheng supercomputer system achieves full-stack independent control from the underlying chips, domestically developed CPUs, and domestically produced HBM, high-speed interconnect networks, and storage systems to the operating system and software ecosystem. The entire system is domestically produced, completely breaking free from the technological blockade of overseas high-end chips and accelerator devices, achieving a leap from single-point breakthrough to system leadership. This signifies that China has the capability to independently build high-end computing infrastructure under technological blockade conditions, completely breaking free from the technological blockade and supply chain constraints of overseas high-end chips and accelerator devices, and gaining strategic initiative in the development of high-end computing power. Second, it breaks through the bottleneck and verifies the capability of domestic substitution. Since the Sunway TaihuLight supercomputer topped the top 500 list in 2017, Chinese supercomputers had failed to reach the top spot for 9 consecutive years due to U.S. technology blockades, bans on high-end GPU sales, and the evolving demands of AI computing power. The Lingsheng supercomputer, with a sustained performance of 2.19 EFlops, the world's first to break the 200 petaflops mark, surpassed systems like the US's El Capitan and Germany's Jupiter, announcing China's return to the top tier of global supercomputing and proving that China's computing power industry can still achieve leapfrog development despite technology blockades. LingSheng is the first domestically developed supercomputer to apply domestically produced HBM, high bandwidth memory, in engineering, solving the bottleneck of data transfer in the AI era and validating China's breakthroughs in advanced packaging and high-end storage, providing underlying support for the independent control of the domestic AI industry chain. Against the backdrop of external chip export controls, the success of LingSheng demonstrates China's ability to leapfrog in the high-end computing field, providing practical verification for the coordinated development of domestic CPUs, domestic AI accelerator cards, and other computing infrastructure, and enhancing the overall resilience of the national computing industry. Third, it reconstructs the computing power paradigm, providing a Chinese solution. Unlike the current global top supercomputers that generally adopt a CPU plus GPU heterogeneous architecture, LingSheng pioneered the online acceleration, all-CPU architecture that embeds an AI matrix acceleration unit on its self-developed LX2 CPU and integrates the first domestically produced HBM, high-bandwidth memory, increasing memory bandwidth by 10 times compared to traditional CPUs. This design achieves a deep integration of supercomputing power and intelligent computing power that a single system can perform high-precision scientific calculations and efficiently run AI algorithms without switching data between different devices, resulting in a qualitative improvement in research efficiency. This architectural innovation breaks through the data transport bottleneck of traditional heterogeneous architectures, achieving performance superior to traditional GPU solutions in some application scenarios. It provides a differentiated computing power foundation construction solution for my country in the AI era and offers a Chinese solution for global supercomputing development. Fourth, it drives cutting-edge innovation and empowers the real economy. LingSheng provides Exascale, 10 to the power of 14, computing power, providing ultimate computing power support for cutting-edge basic research in atmospheric and oceanographic fields, materials science, drug discovery, brain science, scientific AI, and large-scale model inference. Its powerful mixed precision computing and massive parallel processing capabilities can significantly shorten research cycles, such as achieving virtual screening of trillions of compounds and global high-resolution weather simulation, accelerating the transformation of my country's original innovative achievements into real productivity. For example, the LingSheng supercomputing system provides ultimate computing power support for cutting-edge basic research, such as materials science, such as first principles calculations at the scale of 100 million atoms, weather simulation, such as global 1-kilometer resolution simulation, and drug development, such as virtual screening of trillions of compounds, significantly shortening research cycles and promoting a paradigm shift in computation-driven research simultaneously. It empowers industrial upgrading and AI development. The LingSheng supercomputing system provides inclusive computing power for industries such as large-scale AI model training and inference, high-end industrial simulation, and oil exploration, reducing the cost of enterprise digital transformation and AI applications, promoting the deep integration of the digital economy and the real economy, and injecting computing power into the high-quality development of regions, such as the Guangdong-Hong Kong-Macau Greater Bay Area and the whole country. Fifth, it drives industrial upgrading and activates upstream and downstream industrial chains. The localization of LingSheng directly drives the iterative upgrading of upstream and downstream industrial chains, such as domestic high-end chips, high-performance computing, advanced packaging, and high-speed interconnect networks. The maturity of its fully domestically developed technology system provides a solid computing foundation for the domestic AI industry chain, industrial simulation, and digital economy development, promoting the high-quality development of my country's high-end manufacturing and digital economy. Sixth, it empowers China to control computing power and enhance its international influence. After 9 years, China's supercomputer has once again topped the list, regaining its global computing dominance. LingSheng topped the top 500 list of global supercomputers with a sustained performance of 2.19 EFlops, breaking the long-term Western monopoly in high-end computing power and greatly enhancing my country's voice and strategic initiative in global technological competition. The independent controllability of the LingSheng supercomputing system completely avoids external technology supply disruptions and backdoor risks, building a crucial barrier for my country's technological and industrial security. Simultaneously, its top ranking on the global supercomputing list greatly enhances my country's international influence in the global high-end computing power arena, demonstrating the powerful breakthrough capabilities of China's core technologies and injecting strong momentum into my country's technological self-reliance and self-strengthening. A crucial technological asset of a major power. The emergence of LingSheng is a powerful counterattack against Western technological blockade, sending a firm signal to the world that China is committed to independent innovation in the field of high-end computing and building an important barrier for national security and technological self-reliance. In summary, LingSheng's achievement is not an isolated hardware breakthrough, but a comprehensive manifestation of the technological autonomy, industrial ecosystem integrity, and strategic foresight of China's computing power industry. Technologically, it has achieved full-stack independent control, breaking the international monopoly. Industrially, it has constructed a new paradigm of superintelligent integration, leading the technological direction. Strategically, it has solidified the foundation of digital China, empowering major national needs in the future. With the improvement of LingSheng's application ecosystem and the continuous optimization of its energy efficiency, China's computing power industry is expected to occupy a more central position in global digital economy competition. Looking at Lingsheng's achievement as a strategic leap in China's military computing power, the Lingsheng supercomputer's ranking on the global top 500 supercomputer list has value in the military field far exceeding its civilian applications. It is a core carrier for upgrading computing power warfare and algorithm warfare, and has milestone significance for China's accelerated military modernization and enhanced strategic deterrence capabilities. The essence of Lingsheng's rise to the top is the qualitative leap in China's military computing power from following to leading, marking China's occupation of the commanding heights of global military computing power. Its military value is reflected in, at the tactical level, using computing power advantages to achieve precise strikes through battlefield situational awareness, operational plan optimization, and weapon effectiveness enhancement. At the operational level, using algorithm iteration speed to achieve tactical upgrades through asymmetric warfare, cross-domain collaboration, and dynamic adaptation. And at the strategic level, using independently controllable computing power to solidify the foundation of national defense security, strategic deterrence, capabilities, and bargaining chips in great power competition. In the future, with the deep integration of Lingsheng with military scenarios, China will build an integrated intelligent warfare system of computing power algorithm weapon tactics, seize the initiative in great power competition, and achieve a strategic transformation from defensive national defense to proactive deterrence. 1. Dimension of computing power warfare. Building absolute computing power advantage and reshaping the rules of battlefield information game. The core of computing power warfare is using our computing power to suppress the enemy's computing power, rapidly cracking enemy encryption, simulating battlefield situations, and optimizing operational plans through massive computing capabilities. Lingsheng's 2.19 EFlops continuous computing power, the world's first to break the 200 exaflops mark, provides a foundation for dimensional reduction attacks in military computing warfare. Firstly, it enables the cracking of enemy encryption and the gaining of intelligence initiative. Modern military communications, weapon systems, and intelligence networks rely on high-strength encryption algorithms, such as quantum encryption, RSA, 2048, and elliptic curve cryptography. Traditional supercomputing methods require weeks or even months to crack these algorithms. Lingsheng's 2.19 EFlops continuous computing power, the world's first to break the 200 exaflops mark, compresses encryption cracking from a strategic problem to a tactical task, enabling deciphering before the enemy and acting before the enemy. The communication layer enables rapid decoding of communication signals from enemy radar, drones, and command systems to obtain core intelligence such as troop deployments, operational intentions, and weapon parameters. The weapon layer allows for the cracking of encrypted commands from enemy missiles and electronic warfare equipment, enabling unauthorized takeover or command tampering. For example, by cracking the encrypted control protocol of enemy drone swarms, their flight paths can be remotely taken over and converted into friendly combat forces. The data layer allows for the cracking of encrypted formats in enemy intelligence databases and satellite reconnaissance data, directly obtaining strategic-level intelligence, such as nuclear facility layouts and military-based defense systems. That in the future, adversaries may employ quantum encryption, such as quantum key distribution, QKD, to defend against traditional computing power attacks. However, Lingsheng's full-stack autonomous controllability, self-developed chips, compilers, and algorithms allows for rapid adaptation to quantum cracking algorithms. Combined with quantum computing simulation capabilities, it enables the decryption of post-quantum encryption under a quantum classical hybrid computing power, ensuring China maintains the initiative in quantum warfare. The core of intelligence initiative is first to discover, first to judge, first to decide. The Lingsheng supercomputer has reconstructed the intelligence system of modern warfare through full-domain intelligence perception, real-time situation simulation, and intelligent intelligence generation. 1. Full-domain intelligence perception, from single-point reconnaissance to full-domain fusion. By integrating multi-source data such as satellite, radar, UAV, electronic reconnaissance, and human intelligence, Lingsheng can support real-time fusion analysis of hundreds of millions of data points and generate full-domain battlefield digital twins. For example, by using satellite remote sensing and ground sensor data, it can accurately identify the enemy's concealed missile launch silos. By using electronic reconnaissance and AI signal analysis, it can locate the mother machine base of the enemy's UAV for low, slow, and small targets, such as micro-UAVs and balloon reconnaissance vehicles. Lingsheng can combine meteorological and terrain data to simulate their flight trajectory, predict the reconnaissance range, and deploy countermeasures in advance. 2. Real-time situation simulation. From experience-based judgment to precise prediction, war is a dynamic game. Lingsheng can support real-time simulation of millions of variables and generate prediction of enemy combat intentions in seconds. For example, if you input enemy troop deployment, weapon parameters, and logistics supply data, Lingsheng can simulate the success rate of its 3 strategies of attack/defense/retreat and recommend the optimal countermeasured in response to the enemy's combined tactics of electronic jamming plus precision strike. Lingsheng can simulate the response strategy of anti-jamming plus dispersed deployment to reduce our losses. Combined with the super intelligent fusion capability, Lingsheng can learn the enemy's tactical changes in real time, dynamically optimize the simulation model, and achieve more accurate intelligence prediction the more it is fought. 3. Intelligent intelligence generation. From manual analysis to AI autonomous decision-making, traditional intelligence analysis relies on manual screening and judgment, which is inefficient and prone to errors. Lingsheng can support the training of AI intelligence models with hundreds of billions of parameters to achieve autonomous intelligence generation. Automatically identify abnormal patterns, such as frequency changes and signal encryption, in enemy communications and mark them as potential threats. Combine historical battle cases and geographical data to generate enemy combat plans and recommend preemptive strike or luring the enemy deep tactics for new intelligence fields such as cognitive warfare and psychological warfare. Lingsheng can simulate enemy social emotions and public opinion tendencies to generate counter-propaganda strategies to undermine enemy morale. The advantages of Lingsheng supercomputer in encryption cracking and intelligence acquisition are not only information suppression at the tactical level, but also deterrence upgrade at the national strategic level. 1. Constructing an absolute advantage of information asymmetry, contemporary warfare is a game of information transparency. Our side can use LingSheng to grasp the enemy's forces, weapons, and intentions in real time and achieve precision strikes. The enemy, however, cannot crack our encrypted communications and cannot obtain our combat deployment, and falls into blindly responding to the war. This information asymmetry will directly determine the outcome of the battlefield and even affect the course of the war. 2. Strategic capability to support asymmetric deterrence against nuclear powers such as the United States. LingSheng can monitor the dynamics of enemy nuclear facilities and missile silos in real time, support the precise decision-making of nuclear early warning plus nuclear counterattack, and ensure the absolute credibility of second nuclear strike. Against small and medium-sized countries, LingSheng's intelligence suppression capability can form strategic deterrence, forcing the opponent to abandon risky actions and maintain regional stability. 3. Dominating the right to formulate future war rules. The technical advantage of encryption cracking and intelligence generation will be transformed into standard-setting power. Based on LingSheng's technological path, China can lead the formulation of post-quantum encryption standards and AI intelligence analysis protocols, forcing adversaries to rely on China and their technological ecosystems. Through LingSheng's practical verification, an integrated intelligence operation system can be formed, becoming a benchmark model for future warfare and seizing the commanding heights of intelligent warfare. The value of LingSheng in cracking encryption and acquiring intelligence essentially represents a paradigm shift in warfare from firepower dominance to information dominance. At the tactical level, leveraging computing power advantages to achieve a real-time closed loop of encryption-decryption, situational awareness, and intelligence generation, ensuring being one step ahead of the enemy. At the operational level, supporting precision strikes, asymmetric warfare, and cross-domain collaboration with comprehensive intelligence, achieving victory with fewer troops. At the strategic level, constructing strategic deterrence, rule-based leadership, and ecosystem control through information suppression, seizing the initiative in great power competition. In the future, with the deep integration of LingSheng and the military intelligence system, China will build an intelligence-winning system of full domain perception, real-time decoding, and intelligent decision-making, firmly grasp the information initiative in the great power game, and realize the strategic transformation from passive response to active shaping. Second, real-time battlefield situation simulation and simulation. War is a complex dynamic system involving multiple variables such as troop deployment, terrain environment, weather conditions, and weapon effectiveness. LingSheng can support full-domain battlefield digital twins with kilometer-level resolution, complete millions of simulations of red-blue confrontation in seconds, accurately predict the enemy's combat intentions, optimize our tactical plans, and achieve the decision-making advantage of winning before the battle. 1. Technical capabilities, supporting full domain, full element, and full dynamic battlefield simulation. LingSheng's ultra-large-scale parallel computing capability and superintelligent fusion architecture have broken through the bottleneck of precision, speed, and complexity of traditional supercomputing and battlefield simulation, and realized the leap from local static simulation to full-domain dynamic simulation, digital twin of the full domain battlefield. Precise mapping at kilometer-level resolution integrates hundreds of millions of data points from satellite remote sensing, radar detection, UAV reconnaissance, and ground sensors to construct a high-precision digital twin of the entire battlefield across land, sea, air, space, electronic, and cyber domains. Resolution can reach kilometer level or even meter level, accurately reproducing all elements of information such as terrain, weather conditions, troop deployment, and weapon parameters. For example, in mountain warfare simulations, it can accurately recreate the three-dimensional terrain of valleys, jungles, and caves. Combined with meteorological data, wind speed, rainfall, visibility, to simulate changes in troop mobility and weapon effectiveness under different weather conditions. That real-time dynamic simulation of millions of variables. Second-level response to battlefield changes. Traditional supercomputing simulations of a battle take hours or even days, while LingSheng can support real-time coupled calculations of millions of variables, troop strength, weapons, environment, tactics, completing the entire simulation of a red-blue force confrontation within seconds, dynamically responding to sudden battlefield situations, such as sudden enemy reinforcements, weapon malfunctions, and sudden weather changes. For example, in carrier battle group combat simulations, the submarine's trajectory, missile flight trajectory, and electronic jamming coverage can be calculated in real time, and the maneuvering strategy of our ships can be dynamically adjusted to achieve simultaneous simulation and optimization. A superintelligent fusion architecture, the collaborative operation of traditional supercomputing and AI inference, adopts a pure CPU plus superintelligent fusion architecture with an embedded AI matrix acceleration unit, which can simultaneously support traditional physical simulation, such as ballistic calculation and structural mechanics, and AI intelligent inference, such as enemy intent recognition and tactical generation, realizing a closed-loop simulation of physical laws plus intelligent decision-making. For example, in drone swarm combat, the flight trajectory and collision probability of the swarm can be calculated first through physical simulation, and then the countermeasure strategy, such as electromagnetic interference and deception attack, can be generated through AI model to optimize the swarm's cooperative combat mode in real time. 2. Application scenarios, covering all levels of needs from individual combat to joint combat. LingSheng's real-time simulation and deduction capabilities can cover all levels of military needs from individual tactics to strategic campaigns, becoming the core support for precision combat, individual/team tactical optimization, improving the effectiveness of end combat. Simulate the combat scenarios of individual soldiers in complex environments, such as urban ruins, jungles, deserts. Optimize details such as cover selection, fire coverage, and tactical coordination. For example, in urban street fighting, the concealed position and fire blind spot of the enemy sniper can be simulated, and the optimal advance route plus fire suppression plan can be recommended. In counterterrorism operations, multiple plans such as door breaking and entry, hostage rescue, and suspect subjugation can be deduced, and the strategy with minimum casualties and highest efficiency can be selected. Service/weapon system effectiveness verification, accelerating the equipment iteration process. During the weapon development stage, LingSheng simulates weapon effectiveness under different scenarios, replacing some live-fire tests and reducing costs and risks. For example, hypersonic glide vehicles can simulate flight trajectories and thermal protection performance under different atmospheric and meteorological conditions, optimizing missile design and control algorithms. Unmanned combat platforms can simulate scenarios such as swarm collaboration, autonomous obstacle avoidance, and target recognition, verifying the robustness and adaptability of algorithms. Campaign/joint operations simulation, supporting the scientific implementation of strategic decision-making. Simulates the entire process of cross-domain joint operations, such as land, sea, air, space, and electronic warfare, and simulates the probability of victory or defeat for different strategic options, such as preemptive strike, luring the enemy deep, and protracted attrition. For example, in the Taiwan Strait conflict simulation, it can simulate the troop requirements, time costs, and risk probabilities of 3 options: landing operations, blockade operations, and electronic jamming, and recommend the optimal strategy. In the border conflict simulation, it can analyze the combined strategies of rapid counterattack, defensive counterattack, and diplomatic pressure, balancing military strikes and political impact. The new combat concept verification sees the high ground of future war, simulate new combat modes such as unmanned combat, cognitive warfare, and algorithmic warfare to verify the feasibility and effectiveness of the concepts. For example, unmanned combat can simulate the coordinated attack, autonomous resupply and battlefield recovery of unmanned ship swarm and unmanned vehicle swarm, and optimize the command and control system. Cognitive warfare can simulate the changes in the enemy's social emotions and public opinion tendencies, generate counter-propaganda strategies, and undermine the enemy's morale. 3. Strategic value. The leap from tactical advantage to strategic deterrence, the real-time simulation and deduction. Capabilities of LingSheng are not only decision assistance at the tactical level, but also deterrence upgrade at the national strategic level, reshaping the rules of great power game. Building an information decision advantage of enemy-first decision-making. In traditional warfare, decision-making relies on a long chain of intelligence gathering, manual analysis, plan formulation, which is inefficient and prone to errors. LingSheng can achieve a second-level closed loop of intelligence input, situation simulation, plan generation, ensuring that our side detects the enemy first, judges the enemy first, and makes decisions first. For example, before the enemy launches a surprise attack, LingSheng can monitor its troop movements, weapon preheating, and changes in communication encryption in real time, providing an early warning 24 hours in advance and generating a countermeasure plan. After the enemy launches an attack, LingSheng can simulate its attack targets, troop size, and subsequent actions in real time, dynamically adjusting defense strategies to achieve speed against speed. Supporting the overpowering the strong capability in asymmetric warfare. For the side with inferior troop strength and equipment, LingSheng can achieve the advantage of asymmetric warfare through virtual troop multiplication and tactical innovation optimization. For example, under the disadvantage of troop strength, LingSheng can simulate a combination strategy of guerrilla warfare plus electronic jamming plus cyber attack to maximize the paralysis effect on the enemy's logistics and command systems. Under the disadvantage of equipment, LingSheng can optimize the collaborative mode of low-cost weapons plus intelligent algorithms to achieve the tactical effect of winning big with small resources. Dominating the standard setting right for future warfare. Generate adversarial samples to dismantle the enemy's AI decision-making logic. The enemy's AI combat system relies on training data to learn battlefield rules. LingSheng can quickly generate hundreds of millions of highly realistic adversarial samples, such as false target signals, abnormal tactical patterns, and misleading environmental data, and feed them to the enemy's AI system, causing it to learn incorrect rules and resulting in decision failure. For example, in the confrontation of drone swarms, LingSheng can generate pseudo-swarm signals to induce the enemy AI to misjudge the scale of our forces and trigger over-defense or erroneous attack. In the AI command system, false battlefield situation can be injected to make the enemy AI generate self-contradictory combat plans that dynamically optimize countermeasure algorithms to crack enemy AI tactics in real time. Enemy AI combat systems iterate their tactics as the battlefield changes, such as adjusting attack rhythm and switching weapon priorities. Lingqing's ultra-large-scale parallel computing capabilities can support real-time algorithmic confrontation. Through red-blue confrontation simulations, the decision tree and weight parameters of the enemy AI can be quickly analyzed to locate its tactical vulnerabilities, such as weak adaptability to specific environments and low tolerance for sudden interference. Countermeasure algorithms, such as interference deception suppression combination strategies, are dynamically generated to adjust the response mode of our AI in real time. Achieving the more it fights, the stronger it becomes. Suppression effect. Construct an AI immune system to defend against enemy algorithm attacks. The enemy may attack our AI system through algorithm injection, model theft, and other means. LingSheng can support the training of AI security models with hundreds of billions of parameters and construct a multi-layer defense system. Input layer. Identify the malicious data injected by the enemy, such as abnormal sensor signals, forged communication instructions, and directly intercept it. Decision layer. Monitor our AI's decision logic in real time. Discover abnormal patterns, such as instructions that violate tactical principles, and automatically trigger the circuit. Breaker mechanism. Update layer. Combine battlefield feedback to dynamically optimize the robustness of the AI model and improve the immunity against enemy attacks. 2. Computing power suppression. Achieve real-time crushing. With absolute computing power advantage, the core of the AI combat system is real-time data processing plus fast reasoning. LingSheng S2.19 EFlops continuous computing power, equivalent to 2,190 quadrillion floating-point operations per second, can support all-domain, all-element, AI confrontation and crush the enemy system from the computing power level to real-time analysis of enemy AI combat data to achieve one step ahead of the enemy. Enemy AI combat systems rely on massive amounts of data, such as satellite images, radar signals, and communication records, for decision-making. LingSheng can support the real-time collection, cleaning, and analysis of hundreds of millions of data points, generating enemy AI decision-making models within seconds, analyzing the enemy AI's tactical preferences, such as prioritizing attacks on high-value targets and relying on specific environmental conditions. predicting the enemy AI's next actions, such as attack direction, weapon selection, and troop deployment, and generating targeted countermeasure strategies, such as luring the enemy into a trap, saturation jamming, and precision strikes to ensure that our side decides and acts ahead of the enemy. Support for AI cluster collaborative operations to achieve scale suppression. Enemy AI combat systems are mostly deployed as single points or small-scale clusters. LingSheng can support the collaborative computing of tens of thousands of AI nodes to build a full-domain AI combat network. By breaking down tasks such as battlefield perception, decision-making simulation, and weapon control to different AI nodes, distributed collaboration is achieved. Through LingSheng's massive computing power, combat data from each node is synchronized in real time, ensuring globally optimal decision-making. For example, in unmanned surface vessel swarm combat, LingSheng can coordinate the coordinated attack, autonomous resupply, and battlefield recovery of over 1,000 unmanned surface vessels, forming a swarm-level scale advantage that overwhelms the enemy's single-point AI system. Accelerating AI model iteration to achieve generational advantage. The iteration cycle of enemy AI combat systems is typically monthly, relying on live-fire testing and data accumulation, while LingSheng can support real-time iteration through learning while fighting. Through real-time battlefield data feedback, the training verification update closed loop of the AI model is completed within seconds, combining a hybrid training mode of virtual simulation plus live-fire testing. The combat adaptability of the AI model is improved by 3 to 5 times. For example, in electronic warfare AI confrontation, LingSheng can optimize the parameters of interference frequency, power, and time slot in real time, which increases the interference success rate of our AI from 50% to 95%, while the countermeasure efficiency of the enemy AI remains at the old version level due to data lag. 3. Data advantage. Building an information barrier with all-domain intelligence plus autonomous ecosystem. The core of the AI combat system is data-driven. LingSheng blocks the development space of the enemy AI from the data level through a full-stack autonomous and controllable data system and all-domain battlefield perception capability that construct an autonomous AI training data pool to cut off enemy data supply. Enemy AI combat systems rely heavily on public data plus historical battle examples for training data. LingSheng can support autonomous data generation in highly realistic, full-scenario environments, generating data for extreme battlefield environments, such as electromagnetic interference after a nuclear explosion, sensor failure under extreme weather conditions, simulating data for new weapon systems, such as the thermal trajectory of hypersonic weapons, the energy field of directed energy weapons, and constructing cross-domain collaborative data, such as integrated land, sea, air, space, and cyber combat scenarios, ensuring the full scenario adaptability of our AI models. Simultaneously, through encrypted data isolation and autonomous protocol control, it cuts off the enemy's stealing path of our training data, forcing their AI systems into decision-making stagnation due to data scarcity. Real-time contamination of enemy AI data sources, creating an information fog. LingSheng can combine electronic warfare, cyber warfare, and cognitive warfare to contaminate the enemy AI's data input in real time, injecting false targets, such as fake targets disguised as our forces, into satellite reconnaissance data, inserting abnormal echoes, such as false signals simulating enemy missile launches, into radar signals, and spreading misleading instructions in communication networks, such as forging friendly forces in distress signals. Due to data distortion, the enemy AI system will generate wrong decisions, such as attacking false targets, wasting ammunition, and exposing real forces, falling into a vicious cycle of the more the battle goes, the more chaotic it becomes. Dominating AI combat data standards and building an ecological barrier, Lingqing's full-domain data fusion technology can become the data standard for future AI combat. Formulate battlefield data interface specifications, such as sensor data format, communication protocol, algorithm interface, to force the enemy's AI system to adapt to Chinese standards. Build an AI combat data ecosystem, such as data trading platform, algorithm sharing community, to attract global developers to develop AI models based on the LingSheng framework, forming a dual barrier of technology ecosystem. If the enemy leaves the LingSheng ecosystem, it will face the dilemma of data incompatibility, algorithm non-interoperability, and low training efficiency, and its AI combat capability will be suppressed by generational gap. 4. Strategic value. The leap from tactical suppression to rule dominance. The role of LingSheng in suppressing the enemy's AI combat system is not only a technical advantage at the tactical level, but also a rule dominance at the national strategic level, reshaping the game logic of AI war, constructing an asymmetric deterrence in AI warfare. The enemy's AI combat system's decision-making black box, data dependence, and computing power bottleneck put it at an absolute disadvantage when facing LingSheng, our side. Through LingSheng, we achieve full domain perception, real-time decision-making, and precise countermeasures, seizing the initiative in AI warfare. The enemy, due to data contamination, algorithm cracking, and computing power suppression, they fall into a passive situation of blindly responding and making decision-making errors. This asymmetric advantage can form a strategic deterrence, forcing the enemy to abandon risky actions in AI confrontation and safeguarding national security. Dominating the technological discourse power of the rules of future warfare. LingSheng's superintelligent fusion architecture, full-stack autonomous algorithm, and full-domain data ecosystem will become the benchmark model for future AI warfare. Based on LingSheng's technological path, China can lead the formulation of AI warfare ethical norms, algorithm security standards, and data sharing protocols, forcing adversaries to rely on China in the technological ecosystem. Through LingSheng's practical verification, a Chinese solution for AI-human collaborative warfare can be formed, seizing the commanding heights of intelligent warfare. Promoting the upgrade of the war form from AI-assisted to AI-dominated in traditional warfare, AI is an auxiliary tool, such as target identification and data analysis, while LingSheng's superintelligent fusion capability can support the paradigm upgrade of AI-dominated combat. In unmanned combat, AI can autonomously complete the entire process of reconnaissance decision strike assessment, and humans only need to supervise. In cross-domain collaborative combat, AI can Coordinate resources from multiple domains such as land, sea, air, space, and cyber to achieve intelligent command of all-domain joint combat. This AI-dominated warform will completely subvert the traditional human plus equipment combat logic, and LingSheng is the core engine of this upgrade. 5. Suppression paradigm of AI war. From the perspective of LingSheng, the value of LingSheng in suppressing the enemy's AI combat system is essentially the paradigm upgrade of the warform from human-dominated to AI-dominated. Tactical level, achieve real-time countermeasures and dynamic optimization through algorithmic confrontation plus computing power suppression to ensure one step ahead of the enemy. Campaign level, build information fog and autonomous iteration through data advantage plus ecological barriers to dismantle the enemy's AI decision-making ability. Strategic level, reshape the game logic of AI war with technology benchmark plus rule dominance to seize the initiative in great power game in the future. With the deep integration of LingSheng and the AI combat system, China will build an AI winning system of all-domain perception, real-time countermeasures, and intelligent dominance, firmly grasp the technological high ground in intelligent war, and achieve a strategic transformation from passive response to active shaping. 2. Algorithm war dimension, drive algorithm iteration speed, and seize the initiative in war. The core of algorithm war is to subvert the opponent's tactics with algorithm innovation and achieve asymmetric combat advantage through more efficient algorithms. LingSheng's superintelligent fusion architecture and full-stack autonomous controllability provide an accelerator for military algorithm iteration. 1. Accelerating the development of new weapon algorithms. New equipment such as hypersonic weapons, directed energy weapons, and unmanned combat platforms rely on complex control algorithms and trajectory optimization algorithms. The LingSheng supercomputer, with its core advantages such as extreme computing power, full CPU architecture, full stack autonomous controllability, and superintelligent fusion, provides irreplaceable acceleration value for the development of new weapon algorithms, which is mainly reflected in the following 4 aspects. Providing extreme computing power support to achieve efficient solution of complex algorithms. The LingSheng has a continuous double precision floating point performance of 2.19 EFlops, with supercomputing power of 100 quadrillion calculations per second. IT can efficiently handle the massive data calculation, complex physical field simulation, such as electromagnetic simulation and fluid simulation, and large-scale parallel computing involved in the development of new weapon algorithms, and greatly shorten the cycle of algorithm verification and iteration. For example, the LingSheng can support real-time simulation training with hundreds of millions of parameters, shortening the weapon algorithm development cycle from years to months. For example, the trajectory optimization algorithm of hypersonic glide missiles can be iterated from theoretical model to practical use in 3 days through the tens of millions of parallel calculations of the LingSheng. Advantages of the all-CPU architecture, adaptable to the needs of complex algorithms and AI integration. LingSheng adopts a purely domestic CPU architecture without relying on a limited GPU, thus avoiding the programming complexity and data transmission bottlenecks in heterogeneous computing. Its CPU embeds an AI matrix acceleration unit, achieving deep integration of supercomputing power and intelligent computing power. This enables efficient support for the development of AI plus weapon algorithms, meeting the computational needs of complex algorithm scenarios such as long context windows, irregular control flows, and large-scale model inference. Full-stack independent control ensures the security of core algorithm development. LingSheng achieves 100% domestic production of CPU, memory, network, operating system, and software stack, completely eliminating dependence on foreign GPUs and the CUDA ecosystem. This fundamentally guarantees the data and technical security of new weapon algorithm development, providing a solid, independent, and controllable computing power foundation for tackling core algorithms in national defense and cutting-edge military fields that provides a high-fidelity virtual simulation environment to accelerate algorithm practical verification. LingSheng can construct highly confident and realistic virtual battlefield environments by extracting key information in all dimensions and splicing combat scenarios across the entire domain. It can conduct large-sample, multi-constraint simulations of algorithms for new weapons, such as unmanned combat, electronic warfare, and network attack and defense. This enables efficient verification of algorithms in complex environments and extreme boundaries, accelerates the transformation from algorithm design to combat effectiveness, and provides precise computing power support for tactical innovation and weapon effectiveness evaluation. 2. Constructing an algorithm countermeasure system. The enemy may weaken our combat capabilities through algorithm interference, such as GPS deception and radar signal suppression. LingSheng can quickly generate countermeasure algorithms. For example, by analyzing the characteristics of enemy interference signals in real time, it can dynamically optimize our navigation algorithm to achieve autonomous navigation with anti-interference plus high precision, or by generating deceptive signals through AI to interfere with enemy sensors in the reverse and achieve offense instead of defense. Specifically, in the algorithm war, a new form of war with AI algorithms as the core offensive and defensive means, covering intelligent decision-making, automated attack, system confrontation, and other dimensions of future intelligent warfare. Lingqi supercomputer has become a key strategic asset for building an algorithm countermeasure system and competing for the dominant position in intelligent warfare, thanks to its three core advantages: full-stack autonomous controllability, super-intelligent fusion architecture, and top-level computing power scale. Its important value is reflected in the following aspects: technological self-reliance and controllability overcome the bottom-level bottleneck, risk in intelligent warfare. The core of intelligent warfare is the confrontation of algorithms plus computing power. If the underlying computing power relies on foreign technology, the PLA's algorithm countermeasure system will be instantly paralyzed in the event of supply chain disruptions or technological blockades. Lingqing's breakthrough in full-stack domestic production directly solves this Achilles heel. Hardware self-reliance. Equipped with a self-developed LX2 CPU, embedded with an AI matrix acceleration unit, domestically produced HBM high-bandwidth memory, and Lingqi high-speed interconnect network, it achieves 100% domestic production from chip to system, completely eliminating dependence on foreign core components such as NVIDIA GPUs and Intel CPUs. This ensures that the algorithm countermeasure system can still operate stably in extreme geopolitical environments, avoiding the risk of wartime computing power disruption. Software self-reliance. The self-developed full-stack superintelligent fusion framework can release the underlying hardware capabilities to algorithm warfare applications in a usable, programmable, and optimizable manner. The IT supports the customized development of detection and defense algorithms against AI attacks, avoiding the locking of algorithm logic by foreign technology frameworks, and ensuring the self-reliance and controllability of the intelligent warfare command system. Architectural innovation empowerment, supporting superintelligent fusion in intelligent warfare scenarios. Lingqi pioneered a superintelligent fusion architecture, deeply integrating the high-precision numerical computing capabilities of traditional supercomputing with the intelligent computing capabilities required for large-scale model inference, providing a unique technological scenario for offensive and defensive confrontation in intelligent warfare. Real-time AI attack detection and source tracing. Utilizing the massive parallel computing capabilities of supercomputing, it can quickly scan for abnormal AI model behaviors in the battlefield network, such as data poisoning by enemy AI drones, adversarial sample attacks by intelligent weapons, and automated penetration prompt injection. Combined with the real-time inference capabilities of intelligent computing units, it can accurately locate the attack source, attack path, and attack mode, achieving second-level response, and gaining critical time windows for battlefield decision-making. Adaptive countermeasure algorithm development. Through the fusion architecture of scientific computing plus AI inference, it can efficiently train countermeasure AI models. These models can dynamically learn new attack methods, such as deep-fake battlefield intelligence, AI automated electronic jamming, and intelligent decision-making deception, and generate defense strategies in real time, such as adversarial sample generation, model robustness hardening, and electronic signal jamming. This enables intelligent countermeasures, using AI to counter AI, significantly shortening the development cycle of countermeasure strategies and adapting to the rapid-paced and rapidly changing characteristics of intelligent warfare. Intelligent weapon system security hardening. For core equipment in future intelligent warfare, such as AI drone swarms, intelligent firing ranges, and AI command systems, LingSheng can support large-scale red-blue force simulation testing, simulating attack scenarios of enemy AI systems, such as drone swarm coordinated attacks, intelligent decision-making deception, and automated electronic suppression, that it can rapidly iterate. Security patches for intelligent weapon systems, optimizing their robustness and reliability in adversarial environments, ensuring that weapons don't fail. Computing power scale advantage, supporting the high-intensity confrontation requirements of intelligent warfare. The core of intelligent warfare is a competition of computing power density and computing efficiency. The greater the complexity and scale of the enemy's AI model, the higher the computing power requirements for our military's countermeasure systems. With its top-tier computing power of 2.19 EFlops, ranked first globally in the top 500, LingSheng provides the computational foundation for dimensional reduction attacks in intelligent warfare. Large-scale attack simulation and defense verification. It can support the parallel training and inference of tens of millions of AI models, simulating enemy, swarm intelligence attacks, such as collaborative infiltration by millions of AI agents, distributed deepfake battlefield sentiment analysis, and AI-driven automated electronic jamming, verifying the effectiveness of countermeasures and ensuring speed against speed, strength against weakness, in real intelligent warfare, thus seizing the initiative on the battlefield, multitask parallel processing. In intelligent warfare, multiple tasks such as attack detection, countermeasure strategy generation, system defense, intelligence analysis, and command decision-making must be handled simultaneously. LingSheng's high scalability. Average scalability of 84.4% supports the parallel operation of multiple tasks, avoiding the fragmentation of computing resources, improving the overall effectiveness of the countermeasure system, and ensuring zero latency, battlefield response to multi-domain application migration, covering the all-scenario confrontation needs of intelligent warfare. LingSheng already supports applications in multiple fields, including atmospheric and oceanographic applications, engineering simulation, materials science, drug discovery, brain science, scientific AI, and large-scale model inference. Its computing power and architecture can be seamlessly migrated to all domains of intelligent warfare: land, sea, air, space, electromagnetic, and cyberspace. Materials science. Fundamental fields such as stealth materials, high-temperature alloys, quantum computing, and artificial intelligence are the source of vitality for future military technologies. LingSheng can support atomic-level material simulation, quantum state evolution calculation, and large-scale AI model training. For example, by simulating the electromagnetic wave absorption characteristics of new stealth materials using LingSheng, precise matching of materials performance can be achieved in the laboratory stage, accelerating the iterative upgrade of stealth equipment, new weapon and equipment R&D, nuclear weapon simulation, hypersonic vehicle aerodynamic design, directed energy weapon energy field modeling, etc. Rely on supercomputing's billion-level particle simulation and complex physical field calculations. LingSheng can support high-precision simulations with tens of millions of grid cells, significantly reducing weapon development costs and time. For example, in simulating the effects of nuclear weapon explosions, traditional experiments require multiple nuclear explosion tests, while LingSheng can achieve accurate predictions with zero cost and zero risk through virtual simulation. In the field of military intelligence, it conducts red-blue force simulation tests targeting algorithmic vulnerabilities in enemy AI weapon systems, such as autonomous drone swarms, intelligent firing ranges, and AI command systems, developing countermeasures such as AI deception, algorithmic interference, and electronic signal deception to improve the level of national defense intelligence and ensure the PLA's technological leapfrog in intelligent warfare. In the field of cybersecurity, it prevents AI-driven automated attacks, such as AI phishing, AI worms, and AI vulnerability discovery, builds an algorithm-immune cybersecurity system, protects critical military infrastructure, such as command and control systems, radar networks, and communication links, from AI attacks, and ensures zero leakage of battlefield information. In the field of electronic warfare, against enemy AI electronic jamming systems, such as AI-driven radar suppression, communication jamming, and navigation deception, the superintelligent fusion architecture of LingSheng is used to quickly generate adversarial electronic signals, realize electronic warfare confrontation of using AI to counter AI, and regain control of the electromagnetic spectrum. 3. Promote the upgrading of the algorithm war paradigm. Traditional wars rely on the hard power of troops plus equipment, while future wars will shift to the soft power competition of algorithm plus computing power. The superintelligent fusion capability of LingSheng can support the three major upgrades of algorithm war: distributed algorithm collaboration. Through the ultra-large-scale cluster of LingSheng, algorithm tasks are decomposed to global edge nodes to realize decentralized algorithm collaborative operations and avoid single-point destruction. Adaptive algorithm evolution. Combined with the real-time learning capability of LingSheng, the combat algorithm can learn while fighting on the battlefield and dynamically adapt to the enemy's tactical changes. Cross-domain algorithm fusion. Integrate algorithms in the fields of electromagnetic, network, space, and cognition to realize intelligent command of all domain joint operations. Combining the three core advantages of the LingSheng supercomputer: full-stack autonomous control, superintelligent fusion architecture, and top-tier computing power. Its support for upgrading algorithmic warfare can be further refined as follows. First, distributed algorithm collaboration to build a decentralized, resilient algorithmic warfare system. One of the core contradictions of future algorithmic warfare is the single-point dependency risk. If the enemy concentrates its attacks on our core algorithm nodes, it may paralyze the entire combat system. LingSheng's ultra-large-scale cluster capability can support distributed algorithm collaboration, fundamentally solving this problem. Technical implementation logic. Utilizing LingSheng's high scalability, average 84.4%, and the Lingqi high-speed interconnection network, complex combat algorithms, such as intelligent decision-making, target recognition, and electronic jamming, are broken down into hundreds of microtasks and distributed to global edge nodes, such as battlefield edge servers, individual soldier intelligent terminals, and UAV-borne computing units, achieving decentralized algorithm collaboration. Even if some nodes are destroyed, the remaining nodes can still achieve the overall combat objective through dynamic task reorganization, enhance strategic value and resilience, avoiding the risk of system paralysis due to single-point destruction, ensuring the continuous operation of algorithmic warfare. Capabilities in extreme battlefield environments, such as strong electromagnetic interference and physical node damage. Optimized response speed. Edge nodes handle algorithmic tasks locally, such as real-time obstacle avoidance for drone swarms and target identification for individual soldier terminals, reducing data transmission latency and achieving millisecond-level battlefield response. Flexible expansion capability. Edge nodes can be dynamically added or removed according to battlefield needs, such as adding drone swarms or deploying temporary computing units, flexibly adapting to algorithmic warfare. Tasks of different scales and scenarios. Secondly, adaptive algorithm evolution creates an intelligent combat brain that learns while fighting. The key to victory in future algorithmic warfare lies in who can adapt to changes in enemy tactics faster and iterate to develop better combat strategies. LingSheng's superintelligent fusion architecture, traditional supercomputing high-precision computing plus AI real-time inference, supports adaptive algorithm evolution, enabling intelligent confrontation where the battlefield is a laboratory. Technical implementation logic. Combining LingSheng's 2.19 EFlops continuous computing power with its self-developed full-stack software framework, a closed loop of real-time learning, dynamic optimization for algorithm evolution is constructed. Real-time data acquisition. collects real-time data on enemy tactical actions, weapon performance, and environmental changes through battlefield sensors and combat terminals. Dynamic model updates. Utilizes Lingqing's AI inference capabilities to rapidly train counter-AI models, learning enemy attack patterns, such as the collaborative strategies of drone swarms and the signal characteristics of AI electronic jamming. Instant strategy iteration. Feeds learning results back to combat. Algorithms. Dynamically adjusting decision-making logic, such as switching electronic jamming frequency bands and optimizing drone attack paths, achieving learning while fighting and becoming stronger with each battle. Strategic value and tactical generational advantage. Rapidly narrows the technological gap with the enemy through real-time evolution, even creating a generational advantage in algorithm iteration speed. Gaining the initiative on the battlefield, reduced trial and error costs, pre-simulates the effects of algorithm evolution in a virtual simulation environment, avoiding the high trial and error costs of real battlefields, such as weapon damage and personnel casualties. Addressing unknown threats against enemy. New AI weapons, such as autonomous AI tanks and deepfake battlefield intelligence, rapidly generates counter-strategies through adaptive learning, solving the problem of unknown threats. Third, cross-domain algorithm integration enables an intelligent command center for all-domain joint operations. The core characteristic of future algorithmic warfare is cross-domain collaboration. Attacks and defenses in electromagnetic, cyber, space, and cognitive domains require high levels of coordination, and algorithms from a single domain can no longer support the demands of complex battlefields. Lingsheng's multi-domain application migration capabilities, already supporting atmospheric and oceanic, engineering simulation, and scientific AI, can support cross-domain algorithm integration, building an intelligent command center for all-domain joint operations. Technical implementation logic. Utilizing Lingsheng's superintelligent fusion architecture, algorithm models from different domains, such as electromagnetic spectrum analysis, network attack detection, space orbit calculation, and cognitive psychological modeling, are integrated into a unified combat algorithm, achieving real-time sharing of cross-domain data and collaborative decision-making. Electromagnetic domain. AI algorithms analyze enemy radar and communication signals in real time, generating electronic jamming strategies. Cyber domain. AI algorithms simultaneously detect enemy network infiltration behavior and launch automated counterattacks. Space domain. AI algorithms optimize satellite orbits and adjust communication links to ensure zero interruption of battlefield information. Cognitive domain. AI algorithms generate targeted public opinion strategies to undermine enemy morale and influence enemy decision-making. Algorithms across all domains are unified and scheduled by LingSheng, enabling full domain linkage and collaborative operations. Strategic value and joint operational effectiveness are multiplied, breaking down algorithm silos among different services, achieving full domain collaboration across electromagnetic, cyber, space, and cognitive domains, significantly improving the intelligence level of joint operations. Full domain battlefield situation awareness. Through cross-domain algorithm fusion, real-time integration of multi-domain battlefield data, such as electromagnetic spectrum, network traffic, satellite imagery, and public opinion dynamics, generates a full domain battlefield situation map, providing a god's-eye view for command and decision-making, asymmetric warfare capabilities. Through the flexible combination of cross-domain algorithms, asymmetric strikes can be carried out against enemy weaknesses, such as using cognitive domain algorithms to dismantle the enemy's command system, combined with electromagnetic domain interference to paralyze enemy weapons, achieving dimensional reduction strikes at low cost. In summary, LingSheng's full-stack autonomous controllability ensures a secure foundation for algorithmic warfare capabilities. Its super-intelligent fusion architecture supports intelligent confrontation with real-time evolution and cross-domain collaboration. And its top-tier computing power provides support for high-intensity, large-scale algorithmic warfare. The combination of these three elements makes it a core asset in the future competition of soft power in the algorithm plus computing power field, and a key strategic tool for China to compete for algorithmic dominance and ensure national security in the intelligent warfare.